Okay, welcome to SecuPi. Thank you for joining us with a webinar titled Navigating the Risks of Offshore Support and Operations Teams from a Security Perspective. In today, we're going to talk about the requirements and the risks around protection of sensitive data. We'll talk primarily around US customer data accessed by offshore and outsourced teams. We'll talk both about the ability to control access through applications, DirectDB tools, files, even log files that are being accessed by offshore teams. And we'll also show a quick demonstration how all of that comes together when you're talking about a real-life scenario. My name is Alon Rosenthal. I'm SecuPi co-founder and CEO. I've been doing data security for the last 15 years. I'm the inventor of dynamic masking in my earlier time, where I've been over the years have been protecting the most notable brands from UBS Bank, Credit Suisse, from the financials, the major US banks, as well as Swisscom, Vodafone, from telecom perspective, retailers such as Carrefour, and many others. Offshore operation benefits, risks, and challenges. And it's all about reducing the cost of our IT operations. Many large organizations are engaged in massive offshoring. We see that across the board, from large telecom organizations, retail, healthcare, financial organizations are doing a lot of offshore work, where the support, first, second, and third level of support is done from offshore, whether this is India, whether this is Eastern Europe, or whether this is even Indonesia, Malaysia, and other, Thailand and the Philippines. All of those offshore work is done, of course, in countries where they do not have and are not under scrutiny from the perspective of the likes of GDPR or CIPRA, the privacy regulations. Of course, there's an issue around solvency, the requirements to enforce solvency laws, as well as the need to protect data from malicious access, careless and malicious access by different teams. As to perform their operations, whether this is DevOps, infrastructure teams, developers, DBAs, they have an excessive access to US customer data. And of course, this needs to be restricted as much as possible to ensure access on a need-to-know basis. Right? And of course, offshore teams do not have any need to see US client data, US healthcare information of US residents, etc., etc. So how do we, on one side, allow access to perform their actions around applications, log data, files, etc., while restricting access to ensure access is done on a need-to-know basis to address all of those requirements and regulations. In addition to the privacy and compliance requirements, there's also contractual obligations. We see that more and more, for example, from the financials and the telecoms, where B2B customers in financials, right, and as well as in telecoms, a large telecom, for example, in Europe, has been contracting with a government, right, police forces, different type of financial organizations. And in those contracts, there's an obligation that the organization customer data should never leave the premises of the organization. So for example, a German telecom that is contracting with the German government, as an example, would never allow access to the German government telecom information, location, applications, devices, etc., to leave Germany. Okay, that's an example. Or if we talk about a healthcare organization in the US that are performing offshore work by one of the large GSI, the global system integrators, right? Access to the healthcare information of US officials or citizens should not be allowed outside of the US. So this is both driven by contractual obligations. Of course, always the consideration of privacy, of compliance. We talked about GDPR, we talked about HIPAA, we talked about sovereignty laws. Sovereignty laws, both of data on-premise as well as cloud. Sovereignty laws are usually mentioned when we talk about cloud transformation, right? The need to lift, for example, we talked as example of Germany, German telco data to GCP or to AWS or to Azure, right? Regulators are not allowing clear text data to be lifted to the hyperscalers, and this is under the sovereignty requirements, both of the Europeans, but even the specific regulator. The telco regulator in Germany, for example, prohibits access or prohibits the lifting of German citizen telco information in the hyperscalers data stores and data platforms, and they require it to be not only encrypted, but as well as what is called hold your own key. Right? So that's a bit more details around the sovereignty requirements. And last but not least, about streamline operations while reducing cost of those offshore, while applying the identification through masking, through dynamic encryption, filtering, hiding, and other means. The landscape of offshore includes primarily three main areas. Of course, cloud platforms, right? Many organizations are lifting their data sets to cloud, AWS, Azure, GCP, right? They're lifting data sets to cloud, and there, in order to achieve scalability while reducing cost of operation, offshoring is required, and hence a lot of offshore teams are trying to maintain, to control, and to support cloud data environments. On-premise technologies. Still, large organizations are today hybrid, supporting Oracle databases, SQL Server databases, even DB2 databases is done also as part of the offshoring. And a single platform needs to support both the identification and the control on cloud platforms as well as on-premise technologies that are still prevalent in those organizations. And last but not least is providing this on data access technologies. We're talking about the likes of direct DB tools, custom applications, and even just exposing log data, right? Just sending log data from an applications running in a healthcare organization in US. The log data might include patient IDs, patient social security numbers, patient healthcare information, and even the log data that is being generated in those applications to provide support and being sent to offshore. The log data needs to be identified before it is being sent. And we talked about the regulatory landscape, the general privacy regulations like GDPR, CIPRA, DBA requirements, as well as the compliance requirements around SOX, PCI, sovereignty requirements. We talked about that, as well as healthcare regulations such as HIPAA, example of German Federal Data Protection Act. These are specific country and even state-specific regulations that prohibit access to citizen data outside of the state, outside of the country. All of those are changing all the time, which means that the solution, that the way you need to approach offshore requires a platform that will be able to meet additional requirements as they go all the time, right? Of course, HIPAA is an old regulation, but after that comes the GDPR, CIPRA. Today, people are talking about state-level regulations. In the healthcare, even different states are creating their own specific regulations that provide more and more restrictive access on offshore work and offshore activities, as well as the specific regulators, the regulation bodies that are looking at specific countries and specific verticals also add their own requirements on top of all of those other requirements, and hence a platform that will be able to grow with the additional regulatory landscape is required. When we talk about the different personas that we need to protect, right? The personas we would usually divide to three main buckets or identities. The first one is the database administrators, people who have access to the databases that are installing the patches, that are upgrading, that are maintaining the databases, cloning them, patching them. These are identities that have huge amount of access to the data itself. They are holding the database credentials. They hold the keys to the kingdom. And they have both direct responsibility for the production databases, but also to non-production databases. And I'm sure you will not be surprised that a lot of non-production databases also include production data. Non-production databases are, in many cases, still have a lot of sensitive and regulated data that is being proliferated from production to non-production, and hence also the DBAs needs to be, the DBAs, the cloud data account admins need to be under restrictive access and under continuous monitoring. We have the DevOps teams, the Infra support teams. These are the ones who maintain the servers themselves. And of course, in those servers, you will have file shares, you will have databases running on those servers. And hence, also the DevOps teams and Infra support team need to have restrictive access. And last but not least, the application support team. Application support team that are accessing applications in order to support, they are the first line to support some strange behavior in an application. They have admin rights into those applications, and hence, as admin rights to those applications, they not only can access the screens, run the reports of those applications, and see sensitive customer data in those applications. They would also be exposed to log data. They will also be exposed to reporting that can be run on those applications. And they are also needs to be taken into consideration for this data security platform to control all of that. In order to apply those mitigations, right, we need to apply different types of controls. We talk about the ability to identify the data, both in production and non-production, provide also classification of the data. We need to classify what sensitive, what is not, so we can zoom into the identification of the sensitive data, as well as continuously implement more and more restrictive access control. Some a cross-grained policy might be block access to certain tables or to certain database schema. Fine-grained access should be restricting access to federal customer information, or even to certain fields like the CEO salaries, right? So both on an object level, column, row, and even cell level, we need to continuously control access to ensure access is done on a need-to-know basis with this continuous motion into zero trust. Access on a need-to-know basis, the least privilege, right? All of these are major themes of just-in-time and just enough access to sensitive data. For database administrators, of course, the top risks is around access of sensitive data through the DirectDB tools, through the ability just to connect to any one of the cloud data platforms, as well as on Oracle and DB2s with their DirectDB tools, and simply run a select request and access sensitive data. Right? It's very hard to differentiate a legitimate privileged user and a rogue user, and the only way to detect or from a device that is unauthorized, right? That's an easy way to detect suspicious activity, but usually it needs to be over and beyond that by identifying the specific actions that the users are performing and doing self-comparison, peer comparison with other users in the same role help us to identify an abnormal behavior. And I will demo that in a few minutes. Last and not least is the dynamic masking and the attribute-based access control, which allows to take multiple attributes like the location, the device, the role, the citizenship, the consent, and other attributes, and taking all of those attributes into consideration when restricting access to the sensitive data. This is something called attribute-based access control because it takes multiple attributes into consideration before provisioning access to a customer table or to a transaction table. With DevOps, of course, we want to provide restrictive access to servers, to data platforms, to log data protection, right? And this is done by controlling access and de-identifying the access to those files or to those shared drives, whether this is a folder or to log data of application that is being exposed or sent offshore. And this needs to be done by identifying even the data within files, within log data that is being sent. Last and not least is the application support. And here we need to be able to extend the control even to applications, wherever the application support is performed. And it can be a legacy application, like maybe a front office application in a bank. It can be also a CRM application. It can be a different type of application, a COTS application, a custom off-the-shelf application, and even SaaS applications. We need to provide this level of control to identify the data and to ensure that those application support teams can only see data that they are allowed to see to perform their job, not more and not less. How does it all look like from a screen? So a screen of a privileged user that is performing some offshore, you see everything is X'd out. Right? Data accessed by offshore teams that is not required to perform their job, whether this is a DevOps, a DBA, an offshore team, maybe this is an application support team, everything needs to be X'd out. A quick example, this is an example of a direct DB tool. It's called dbeaver. Some of you might use dbeaver, but similarly, the same data identification, the same Xing out, filtering, reducting needs to be performed on any direct DB tool. In this example, again, it's dbeaver. It can be SQL Plus, it can be Toad, it can be SQL Navigator. There are dozens of different tools that organizations are using from their mainframe, Oracle, up to RDS and Azure SQL, Snowflake, and Databricks. The identification needs to be done in a single platform where in a consistent policy should be enforced on all access through those different direct DB tools to all databases from on-prem to the cloud. When we talk about production support to applications, this is an example of such a custom off-the-shelf application. What we are doing at this customer is once a production support team member logs into this application with no code changes, by simply putting SecuPi Enforcer on this application, you can see that the production support work is done with the identified data. Right? The name, the commercial name of those customers is completely hidden, as well as the social security number is also X'd out. Okay, the identification is performed only on the production support teams accessing this application from India. If I would log into this application, if a business user would log into the application, the commercial name will be seen in full. So the selective identification performed in this case on applications, previously we showed it on a direct DB tool, is what is required to address the offshore regulations and data security requirements. How can it be done on all of those platforms in one? The way that it is performed is by installing a SecuPi management server, right? This is the central command post, the control plane to control all of those activities for all offshore work. Once the management server is installed, and this can be installed either on-premise, or as we support the US government, it can be installed even on a dark room, as well as in any one of the cloud Kubernetes cluster. It can be configured on an AKS, EKS, ECS, etc., or JKE. And once the management server is installed, then what we do is we push from the management server the different enforcers in order to apply the identification from to the offshore team applications and tools. So once the management server is installed, we then push down different type of enforcers and configure them on the tools, on the applications, and they come in different ways. Why do they come in different ways? Because, of course, to support from the mainframe to your RDS, from Exadata, Teradata to Snowflake and Databricks, we need different ways because these are really variety of technology that we need to support. And in order to support that, we provide 5 different ways to do that. Either for the more modern technologies, it can be done in an agentless native approach, for example, Snowflake or Databricks. It can be done by putting SecuPi on the applications. We have an application-based enforcer where we put a SecuPi component on your applications, which will be performing the monitoring and the access control. It can be also part of, it can be also provided as an API or an SDK as a transparent gateway, and even can be configured on your ELT, ETL tools when, for example, Informatica or Talent or Databricks or Azure Data Factory is crunching data, is performing some operations and creating files or creating log data, the data that they're creating will be identified. So these are the different ways that the SecuPi is enforcing its policies to protect offshore work. Of course, in order to identify those offshore teams, we need to have context. We need to have the user context. And that's why the management server, this control plane, also is integrated with your identity and access management. If, for example, to identify a user based on location, the role of the user, the citizenship of the user, his authorization can be pulled, for example, from Azure AD, from LDAP, from SailPoint, from Savient, from Okta, right? And even from HR systems like SAP HR or Workday. So we are pulling the user attributes to identify those offshore teams automatically. And then based on those identifications and based on policies that we centrally defined, then everything is being pushed down to the relevant enforcers to take action on those direct DB tools, on applications, on log data that are being processed by an ETL tool or an ELT tool, and all of those are synchronized continuously with the policies that are defined centrally. So that's a quick explanation of how such an offshore platform can help you to overcome the criticalities of data protection, both from applications, where we simply put SecuPi on a custom off-the-shelf application, as well as on direct DB tools, where SecuPi can even act like a transparent gateway between those direct DB tools and your 2000 RDSs and 500 Oracle databases on premise, as well as by putting SecuPi on the ETL ELT tools, we are able to identify sensitive customer data in files, in log data, etc. Another way to look at it is to look from the data perspective, because we might find critical data, namely, for example, even credit card information or federal customer data, right? It belongs to the US government. For those types of columns, for those types of rows, we might suggest to completely encrypt them or completely redact them. For a lesser restricted information, for confidential or for internal data, there we might suggest not to apply encryption, but for those we might suggest to apply masking. Maybe for internal data, we might just apply maybe dynamic masking or just applying logging and auditing as a compensating control. So also looking from the data perspective, we might apply different type of policies based on the criticality of the data and the impact of such a data to be exposed offshore. And of course, this aligns with the other viewpoint of the persona. Right? We talked about 3 different personas. We talked about the DevOps, we talked about the DBAs, the developers, we talked about application support teams. For different personas, I can also apply different types of controls. So all of these are defined centrally in the SecuPi control plane, where we define, based on the identity of the user, the type of the data and what type of controls we want to apply to the offshore team, to the outsourced teams. This eventually also is being created in the SecuPi management server, and let me show you quickly how it all fits together from the SecuPi management server, because until now we just show you how the identification occurs in an application and in a direct DB tool. When I log into the control plane, right, in the control plane, I can define those controls to ensure access to the data based on attributes, based on different attributes. Let me try to find SecuPi management server to show you that. This is a new laptop, so okay, good. So we talked about the two elements, both of applying the identification and now I will also show you that from the monitoring perspective, right? As we want to continuously monitoring the user activities, and you can see that the activities of the users are monitored continuously in the SecuPi management server. So not only that we will be identifying the data, as I've shown you, Xing out access to the customer data, I'm also, in addition to the identification, SecuPi will continuously monitor the performance and the actions done by those offshore teams. And here you can see that Adam Thompson, this person that from India that logged into this application called Open Bravo from this IP, he's looking at 60 rows of PII and phone numbers and email and social security numbers. Those classifications can either be generated by SecuPi or can be imported from any one of your catalogs, Elation, Colibra, Big AD, and other types of data catalog and other types of data classification tools, PeerView and others. So based on those classifications or our classifications, we will classify all activities to the sensitive data that you have, in addition to providing a risk score to those activities. And we can even drill down to the specific activity and identify not only the username, but even the user role, the risk score associated with this request, the risk score based on the volume, the velocity, and the variety of the data that is being exposed, and even have the full forensics around these offshore person activities, even the request itself. So this is the granularity of the audit trail that SecuPi provides. On top of that, we come to more of the bird's view, where we can look at the user and analyze the user behavior over time, over the last 3 months' time, and do self-comparison between this application administrator and other application administrators, seeing the variety of the data that the variety of sensitive data that this administrator has been accessing compared to his median, compared to his peers, and compared to himself over time. So this is the observability that you provide. Of course, all of this information is provided also to your SOC. So the SOC team in your organization can also analyze this information and correlate it to other events that they might identify at this offshore person desktop and other types of sensors that they have. And we talked about the policies that SecuPi will be applying to identify the data, and the policies are seen here, where we can define policies based on columns. We can define, so for example, all offshore team roles, the roles associated to the offshore teams. When they access PII data, every data needs to be masked or encrypted, right? Or allowed to be seen in clear. So based on the roles of the offshore teams, we can decide what type of identification we want to happen based on different data categories. PII, PHI, PCI data. For every type of data category, we can define different type of the identification. This is aligned not only with the column level, but we can also do it on an object level, allowing access to the customer schema, yes or no, and even on the row level, right? Filtering out maybe Swiss client data when performing offshore work on a banking application that is serving those Swiss client data as well. So this is a brief of how the policies are being defined, in addition to the observability that we provide in real time. We need both observability to detect suspicious activity, malicious actions, as well as the access control policies to restrict access on a need to know as much as possible. And this is summarizing what we are able to do, both from a security, a compliance, and privacy perspective, from those applications running on-prem or in cloud, databases running on-premise or cloud, and even file data that is being accessed by offshore teams. This summarizes what I wanted to share with you today in this session, overcoming offshore challenges and addressing data security, compliance, and solvency requirements for offshore teams. Thank you very much for being here and participating in this webinar. And we'll be happy to answer any more questions you have by simply reaching out to us through the different channels, sending emails, as well as we'll be here to address any type of challenges you have. Thank you very much, and I look forward to meeting each and every one of you soon. Thank you very much.